Hello and welcome to this lesson about the distance formula. The learning target of this video is to use the Pythagorean theorem to find the distance between 2 points. What I'd like you to do is consider this. What we have here is the makings of a triangle. So I'm going to connect this with the origin. Because what we want to do is find the hypotenuse, find the distance from those 2 points. Now I picked these points intentionally because if you take a look at it, this point is 3, 0, and this point is 0, 4, meaning that the distance from the origin to the one on the x-axis is 3, the one on the y-axis is 4, and since this is a right triangle, we have a 3, 4, 5 Pythagorean triple, and we know that the length there is 5. Now, I'm doing this to make a point. We can use the x and y coordinates to find the distance from where these x's and y's would meet if there were lines that connected them to a triangle. And so ultimately, this is how we're going to use the Pythagorean theorem to help us out. So you have to keep in mind, the Pythagorean theorem is a squared plus b squared is equal to c squared. And that if we're trying to find a formula that just had c, or was solving for c, we would need to take the square root of both sides. And so c equals the square root of a squared plus b squared. And what we're going to do is, with the distance formula, expand on what a and b are, and use an expression instead of just a whole number. So let's walk through another example. Now take a look at the difference here. All I did is I shifted that 3, 4, 5 triangle over a little bit to help make a point. So in yellow, let's find the length of this. It is 1, 2, 3 units. And then the height of this little triangle is 4 units. Now, let's look at the points and see if we can derive something from this. So the point of this, on the left-hand side here, is 1, 5. The point on the right-hand side is 4, 1. And right here, this point, which I'll just kind of mark in a neutral color here, is 1, 1. And so if I wanted to find the length of the yellow, what I'm going to do is use this x and find the difference between them. And so the length of my yellow line is 4 minus 1. And that's where you can get 3 from. If I want to find the length of my blue line, I would use this y-coordinate and that y-coordinate to get 5 minus 1, and that's where I'm getting the 4 from. All right? And so now what we're going to do is make things a little more complicated, and jump up a little bit here. We're going to sort of ignore this point, pretend it's not there, but we are going to use every coordinate right there. And so I'm going to tell you what the distance formula is. So the distance formula. The distance formula, d, is equal to the square root, and notice how long that radical is because we're going to need a lot of space, my 2 x coordinates, x2 minus x1 squared, plus my 2 y coordinates, y2 minus y1 squared. See, I even needed a little longer radical there. And what x2 and y2 correspond to and all that other stuff is these are the 2 points. And so like this could be point 1, this could be point 2. And so to plug this in, if I were to plug this in, I'd end up getting, so x2 would be 1 minus 4 squared plus, and then y2 is 5 minus 1 squared. And it ends up becoming the same thing. And it helps us calculate the distance. And all this is a variation of the Pythagorean theorem. On the previous slide, we saw that to solve for c, the hypotenuse, it's equal to the square root of a squared plus b squared. Well, to find the length of a, you do that. To find the length of b, you would do that one. And so it's the Pythagorean theorem solved for the hypotenuse in a slightly different look. Now, do make sure that you have that written down, because you're going to need that and have it committed to memory in order to help you solve these problems. And so now that we've kind of worked on deriving the distance formula, let's do a couple of examples with it. All right, I just realized that all my examples are of negative slopes. It doesn't matter if it's going the other way. The principle, the concept works the same. And so the first thing we're going to want to do here is identify what our points are. And so this one, I have 1, 2, 3, 9 as my y. Over here, I've got 12, 1. And so I have my 2 points, and now it's just about using the distance formula. So, especially when you're new at it, maybe write the whole thing. So, x2 minus x1 squared plus y2 minus y1 squared. There we go. Now, start plugging in the points. All you have to do is be consistent. So whatever one you pick to be 1, you use for both x and y. Same thing with whatever one you pick to be 2. So now distance is equal to the square root of 12 minus 3 squared plus 1 minus 9 squared. Now the cool part is that you don't have to worry about negative signs, because when you square something, you're going to get rid of the negative. And so d now equals the square root of, so 12 minus 3 is 9, so 9 squared, plus negative 8 times by negative 8 would be negative 8 squared, so there's that. And so then d equals the square root of 81 plus 64. And then what we're going to find out is that for a lot of these, they're not going to always work out perfectly. You're going to get awkward square roots, and that's fine. And you're going to have to do some rounding. So here we'll get the square root of 145. And then if we were to round that, we would end up getting about 12.04. Oops, 12.04. And there we go. And so that's the length between these 2 points, 12.04. Let's do one more example. Now in this example, we have negative numbers for the points, and that's going to matter. So we got to pay attention to those. But just like with the other one, it doesn't hurt to write down the point. Well, you should write down the points. So here we got negative 2, 6. And then here we have 9, negative 1. And then again, at the very beginning, just for good practice, write down the distance formula. So there we go. And then pick a point, 1, 2. Again, which one you actually know it, just to prove it. Let's do it. Let's mix it up. 2, 1, doesn't matter. All right, d equals, and then here, let's go with negative 2, and then minus 9 squared, plus, and then y2 is going to be 6 minus negative 1. Squared, and then we'll take the square root of all of that. Now, the reason why I have this example in here is we got to watch out for the negatives. We're going to have to deal with negative number arithmetic. So negative 2 minus 9, that's going to be negative 11 squared. Plus negative 6 minus negative 1 is the same as 6 plus 1, and so that's going to be 7 squared. And again, we're going to take the square root of all of that, and so we get 120, square root of 121 plus 49, which is 170. So the square root of 170, which roughly equals 13.04, give or take. And again, that represents the distance from here to here. Now, what the distance formula is helping us do is count from one point to the other point if we were to make a right triangle. And to go from negative 2 to 9, it is 11 spaces. And to go from 6 to negative 1, it is 7, or that would be 7 spaces. So 11, 7. And now you're just doing the Pythagorean theorem. And so you could ultimately just do this if you wanted and count it all out. But you're going to do the same amount of work. You got to square it, square root, all that other stuff. So the distance formula just helps you do that in one move, if you will. So good luck with your homework, and let me know if you have any questions.